Alright, calculus, we are looking at AB 40 with the inverse trigonometry. So we kind of know trig. We know especially things like SOHCAHTOA, mostly, that's pretty much mostly what we need to know is how to use SOHCAHTOA and a little bit of special right triangles, which we're going to pull in here. But the idea of doing something inverse is really doing it backwards. So when we look at, sine of 30 degrees, and we think, oh, what's sine of 30 degrees? Oh, what was that? It's like 1/2 or something. The inverse style of trigonometry here is really saying sine of what equals 1/2. And the question is not what's the end of it, it's what's the middle. And the way that we write that, and really the notation is probably the most confusing part about this. It's sine to the -1 of 1/2. And that's what these two things mean here. They're the same thing. It's really just asking sine of what is 1/2. That's really the question. So, and you've done this before, and you're like, that sounds so hard. It's called the same thing as doing things in inverse order, where you take out the middle part or the end part. So, for example, you guys did something like 2 plus 3 equals, and you say, that's 5, duh. You did that when you were a kid. And then somebody else said, well, what about if I did 2 plus something equals 5? Figure that one out. Like, I think it's 3. Okay, so same idea, same equation, same relationship as far as, both sides equal 5, but how you go about working through these problems requires a little bit better understanding to fill in a middle piece, like here, where we're going to do some type of inverse relationship. So let's iron out some details here. With inverse is right here, interchanging the variables. So y and x, those just change places. So when I have y equals 2x plus 6 to start with, that turns into x equals 2y plus 6. Oh, how did that happen? Okay, so I got that. And then I'm thinking, okay, if f of x equals 2x plus 6, that's like y equals 2x plus 6. But then to switch it around, I'm going to say x equals 2y plus 6. Now I would do some algebra to solve this for y. I'd have x minus 6 equals 2y. Divide everything by 2. And then that gives me 1/2 x minus 3 equals y. Or, writing it the other way around, f inverse of x is 1/2 x minus 3, which is what's happening there. So that's the general idea. You switch x and y. Y becomes x becomes y, and you see what happens. The other thing worth noting as far as visual representation here, it's reflected across this diagonal line y equals x. And the inverse relationship, pretty much, it's kind of like you twisted the axes. Because guess what? This was the y-axis and this was the x-axis. But when you switch x and y, those things change. So more details on this. It does not mean the reciprocal. That's for sure something you want to keep in mind. It's not the reciprocal. And we're only really looking for things that are invertible. And how does that really play into it? So for example, this term here, we got x squared and square root of x. Kind of. Because when you think y equals x squared, and then let's say we switched it, and we got x equals y squared, and then we square root both sides. Say, well, that's the same thing, Mr. Butler. Square root of x equals y. Well, but the catch here is when you take a square root, you really consider plus or minus. And this one's only the plus, which it has to be, because if I were to do the bottom side here, the minus square root of x, check this out. Point, vertical line, ooh, not a function. So that's not invertible. Kind of. It is if we restrict it to just the positive, which is kind of implied here, but not necessarily. Let's get more specific here with some trig and how those look. So this is sine, And if I were to flip that, y equals sine of x, and if I were to flip it and say x equals sine of y, this is what would happen. Now this is not 1 over sine of x. This is not 1 over sine of x. It's not just the reciprocal. So even though it says like to the -1 power, and we generally think, well, that just means in the denominator, it's not so true here. So the problem, as you guys hopefully are seeing here, is that this doesn't pass vertical line test. Look at that, 1, 2, 3. It fails it as soon as it passes the second time. But in fact, it would probably have multiple passes the further down you go. So then what do we have to do to account for that? It's kind of bolded on your paper, but it's really looking at just one section, one restricted section, where in the x range, it goes from -1 to 1. And in the y range, it's going from -pi/2 to pi/2. And that's kind of important. That's saying that you're possible for, if we have cosine of y equals x, that tells me that y has to be between these two values, -pi/2 and pi/2. Now, could I have restricted a different one? Yeah, I could have gone from -3pi/2 to -pi/2. But it doesn't really matter. So we usually just aim for the zone around 0. Similarly, cosine has some different things here as well. So sine, we have that. But for cosine, it's 0 to pi. Because check this out. We have the same interval from -1 to 1 horizontally, but now we got to split it from 0 to pi for these answers. And for tangent, we have the -pi/2 to pi/2 here. So that's -pi/2 to pi/2. So they all have this interval that's a pi in length, but in reality, cosine here, we got from 0 to pi. Then the other two are from -pi/2 to pi/2. And that's how we got to restrict it in order to keep this balanced. We have to restrict the range. So all our answers should be in the appropriate range. And we'll see how that plays out here in a second. Okay. So this note, we're going to come back and see that later. You got to know conversions from degrees to radians and your special right triangles. That's almost more important. Here's a summary of kind of what we just said about the restricted range. But here's some notes on degrees and radians. You got to know this. Some things to look for. Okay, so when it's a 45 degree kind of thing, that's pi/4, 3pi/4, etc. And if we're going all the way to 180 degrees, well, pi/2 and pi is like 90 and 180. But look at this kind of action. So 30 degrees has pi/6, 60 degrees has pi/3. 120, which is a partner of kind of 60 degrees, is over 3. And 150, which matches 30 degrees, pi/6. So this is really like the 30s, the 60s, the 60s, the 30s. We got 45 here, 90, another 45 there, and then another kind of like a 90, I guess. Now for 30, 60, 90, 45, 45, 90 triangles, keep in mind these shapes. One alternate version should be that you not only memorize this version of 30, 60, 90, but if you think about it, what if it was tilted the other way? If this base angle was 60 and the top angle was 30 degrees, then we'd have 1, 2, square root of 3 like that. So depending on how you draw it, how you piece it together, that's how the options will look. Now, of course, these will match every time, and any time that it doesn't necessarily look like this, you can always come back to this with like a proportion or something like that. Or some, just numerical manipulation. We'll see all that stuff. So let's start with the beginning. Evaluate each of the following. Alright, so this first one, it says arc sine of -1/2. What is that really saying? That's saying sine of something equals -1/2. Well, that could be three different things. That could either be -1/2, actually really, it's any one of these. Okay, so now when I look at these pieces, there's a couple things going through my head. The first thing is special right triangles check. I got to figure out which one that works on. And then I'm also considering SOHCAHTOA. Just a simple acronym that's really helpful here. We're looking at the sine group. So for sine, that means these pieces are opposite and hypotenuse. That means my 1 would be an opposite and a -2 would be my hypotenuse. Well, I actually, if I were to look at the hypotenuse, it's kind of a little more challenging to think of the hypotenuse as a negative, so I'm going to ignore this last one. But I am going to look at this middle one. So that would mean a -1 for my opposite piece. So let's say here's my start point. I'm going to go -1 in the opposite side, and that's kind of my vertical distance. And then my hypotenuse here is 2. So then the question is, what's this angle? That is the question. Well, if I were to look at this, I really think this is like a 30, 60, 90 triangle. So this side would be 30, this would be 60, that angle would be 30, and this angle would be 60. How does that help me? Well, I rotated down, which is actually a negative rotation, so that's -30 degrees. Now, considering this is calculus, we need to translate that into radians, so that's going to be -pi/6. There we go. So that's our answer. The answer to this is -pi/6, because the question really was, when does sine equal -1/2? Okay. Now, somebody out there who's trying to be a smarty pants might ask, but wait, Mr. Butler, we know that 11pi/6 is the same thing as -pi/6. Yeah, it is. But numerically, for our answer, this second one is more appropriate. Well, why? And this is part of that note that I deleted earlier. So -pi/6 is more appropriate. And here's why. So if you go back and you look at our restricted range for sine, -pi/6 fits in this range. 11pi/6 is actually outside of it. So we're not really wanting to write it like that. We want to write it like this, -pi/6. So there we go. Next one. Let's kind of work our way through these one at a time. This next one is just asking cosine of what equals 0. Well, I think of this as cosine of 0/1. So cosine is really the adjacent side over the hypotenuse side. So if I were to consider 0/1, I'm thinking, like XY axis. I don't move at all for my horizontal, but my vertical goes straight up 1, which to me says, I got a line like that. So how far is this angle here? Well, that's 90 degrees. But what would that be in radians? Well, that's pi/2. So the answer here, pi/2. Alright, for the next one, and hopefully you guys are starting to catch on to some of these little in-between steps that help us quite a bit. First thing I'm going to do is think of this as √3/1. And then the next question that we're going to ask ourselves is, what group are we looking at? It looks like this time we're looking at tangent. So tangent is going to involve the opposite and adjacent. And the question here is, tangent of what equals √3/1? Well, √3 would be our opposite side, and 1 would be our adjacent side, because it's opposite over adjacent for tangent. So if the opposite side is 3, or √3, and the adjacent side is 1, it's really asking what angle or what triangle are we talking about here. Well, this looks like this would be our 60 and our 30, because this is √3 and this is 1. This would be our 2. So that means this is our opposite. We're talking about 60 degrees. No problem, 60 degrees. But wait. It's got to be in radians. Okay, so 60 degrees is pi/3. There we go. Cosecant. That's crazy. How do we deal with cosecant? Well, cosecant is really 1 over sine. So we think of cosecant theta equals 1 over sine theta. That's going to help us. And it's the reciprocal then. So if you think of sine is opposite over hypotenuse, this time cosecant is going to be the hypotenuse over the opposite. Alright, so that's a start. Let's work with that. So we're trying to see cosecant of what equals negative square root 2 over 1. Remember, this is always over 1, and that's always going to be helpful to us. So the hypotenuse, let's keep the hypotenuse positive and then use the opposite side to be negative. So this is our hypotenuse, and this is our opposite. So the hypotenuse is square root 2, but the opposite is negative 1. There we go. Okay, so what would this match? It looks like this would be the 45-45. So we're talking rotating down, which is negative. So this is negative 45 degrees, no problem. But that's not the actual answer. The actual answer would have to be in terms of radians. So that'd be negative pi divided by 4. There we go. That's the finale for that evaluation there. So what are we really looking at? It's saying that trig inverse of some number, let's call this x, is really saying trig of what angle is equal to x. And the question is more about this angle than it is about your finale. So let's look at some more kind of layers, combination plays here. Okay, so this one right here, we have sine and arctangent. So how do we deal with that? This is kind of crazy. So a picture is actually going to break it down for us even better. So we're going to start here with arctan 3 over 4. What that says to me is that the 3, if this is tangent, thinking TOA, that's going to have the opposite and the adjacent pieces. So because I'm dealing with the opposite and the adjacent pieces, I know that my opposite side is 3, my adjacent side is 4. And then here's my theta, you could say. Now for us to find sine of theta, because the question here, we would get some angle theta for that. Sine of that answer is going to be the opposite over the hypotenuse. Now that wouldn't be that big a deal, except we don't know what the hypotenuse is. It's a question. But we do know this is a right triangle, and we do know Pythagorean theorem. You guys are probably even already there. You're thinking 3, 4, I know the answer to this, because 3 squared plus 4 squared equals the hypotenuse squared, and that's 9 plus 16 equals the hypotenuse squared, which is going to give me 25 equals the hypotenuse squared. So 5 is my hypotenuse. And you might have memorized that from a triple, Pythagorean triple is what we would call that. So that's my hypotenuse, 5. So when I'm asked to figure out sine using the opposite and hypotenuse sides, well, the opposite in this case is 3, and the hypotenuse is 5. So there we go. It's a two-stage process. So first thing that we're looking at is theta with a picture, with a triangle, and then we're gonna find any missing parts. Find all parts, and then we write the ratio. So let's look at this next one. We have our cosine square root 2 over 2. So that to me says, that we got, what are these two pieces? So cosine, C-A-H. Cosine would be adjacent over the hypotenuse. So my hypotenuse is 2. My adjacent is square root of 2. And how could I figure out the missing side? Well, I don't know. Not yet. Pythagorean theorem, though. So this is my adjacent. This is my hypotenuse. Here's my opposite. And I know that square root of 2 plus the opposite squared equals the hypotenuse squared, which is 2 squared. Okay, so let's each of those should be squared. A squared plus B squared equals C squared. Old school Pythagorean theorem. So 2 plus opposite squared equals 4. Opposite squared equals 2. So that means that the opposite is square root of 2. Okay, so opposite is square root of 2. How do I deal with that with these pieces? So opposite, why do I need that? Oh, here's why. Because I need to define tangent. And to find tangent, that's a tangent of that angle, that same angle here, here's theta. It's going to be the opposite over the adjacent side. Now that I know the opposite, which is square root of 2, the adjacent side is also square root of 2. So that's just 1. Well, that was simpler than I thought. So sometimes we use special triangles, sometimes we use Pythagorean triples, and those work out nicely. Here's one that's going to be a little more sloppy. Not too big a deal, but, you know, a little bit. So let's give ourselves some space. So I'm looking at sine inverse. And if this is sine on the inside, that means that 1 is the opposite. How do I know that? Well, sine, the so of the SOHCAHTOA, means that 1 is our opposite, 3 is our hypotenuse, because it's opposite over hypotenuse. So opposite is 1, hypotenuse is 3. The question mark is that third side, because here's my theta. How do I find this third side? Well, I know it's the adjacent side. And I know that the adjacent squared plus the opposite squared, which is 1, equals the hypotenuse squared, which is 3. 3 squared. Well, I should say that's 9. So it's 9 equals 1 plus the adjacent squared, and then we got 8 equals the adjacent squared, and then adjacent equals square root of 8. No big deal, right? So this side equals square root of 8. How does that help us? Okay, so we're looking for secant. And secant is going to be 1 over cosine, where cosine was adjacent over hypotenuse, so secant of theta is going to be the hypotenuse over the adjacent. What are those two pieces? Well, the hypotenuse is 3. The adjacent is square root of 8. Are we done? Technically, yeah. But we got these old crazy fuddy-duddies writing the tests, and they feel like that's not good enough. They feel like you got to keep this piece here on the bottom not really there. Like they don't want it at all. So in other words, they don't like square roots on the bottom. Why? I hope you guys know why. It's an old historical tradition dealing with slide rules. Okay, so we got square root of 8, and to rationalize that, we have square root of 8 over square root of 8. Then we got 3 square root of 8 over 8. And then they'd say, well, that's not even enough yet, because square root of 8 can be broken up into square root of 4 and square root of 2. So that would make this equal, and this is not less than or equal to. It's just a typo. So let's correct that. It's just equal. This would be 3, because over here square root of 8 is 2 root 2. 3 times 2 square root 2 over 8. And then they'd simplify the 2 and the 8. We get a 4. And then it's 3 square root 2 over 4. That's crazy long, but please keep in mind that this original answer is just as correct as the last one. The difference is just simplifying. Okay, more. So one more of these. We're looking at cosine. That means that the 2 is my adjacent, and it's negative. I'm going to keep that in mind. And the 5 is the hypotenuse. Because ka, so ka, toa, is adjacent over hypotenuse. So adjacent's going to be negative 2. And 5 is going to look like this. We're really talking about this theta. but that's kind of irrelevant because, well, no, it's not that irrelevant. We're going to be looking at cotangent of our answer here. So what are we going to get? Oh, I don't want to write that in red. Let's see what we can do here. This is our third side. Here's our theta. We're trying to figure out this third side. How do we do that? Well, we know that negative 2 squared plus this opposite side, it's the only side we're not using, squared, equals 5 squared. Okay, so do some algebra here. We got 4, 25, opposite squared. And then we get opposite. It's going to be square root of 21. Okay, so square root of 21 equals opposite. And don't forget this negative 2 goes with the adjacent. And that's going to be helpful because cotangent is equal to 1 over tangent, which is really talking about the tangent ratio reciprocated, flipped for the reciprocal. So tangent would normally be opposite over adjacent. So 1 over that is going to be the adjacent over the opposite. So cotangent theta is equal to the adjacent side, which is negative 2, over the opposite side, which is square root of 21. And I'm not even going to bother with the old school rationalize the denominator. I think that's good enough. But if you wanted to see it, it'd be negative 2 square root of 21 over 21. Okay, keep going. Dun, 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 dun. What's next? Ooh. All right, so this one, I did most of these in part 2, but I'm going to go ahead and do them here and finish them out as well. I just didn't do the first one. So what's the difference now? The difference now is this ratio is not a number. It says x, but you need to keep in mind that it's also got a number attached to it, x over 1, because all these SOHCAHTOA pieces are talking about a ratio. So we know that sine is really opposite over hypotenuse. So I'm going to draw a triangle. Oops, not that. Opposite is x, and hypotenuse is 1. And it's asking me to do cosine, which is really adjacent over hypotenuse. So I got to figure out this adjacent side. I don't know what it is. We'll just call it A. Well, I know that a squared plus x squared, so the adjacent side plus x squared equals 1 squared. So if I do some algebra here, I get this, and then even further, the adjacent is square root 1 minus x squared. So this piece here is square root 1 minus x squared. How does that help me? Because cosine of theta, because this is really theta, that's what we're trying to figure out here. Cosine of theta is equal to the adjacent side over the hypotenuse side, which in this case is square root 1 minus x squared all over 1, because the hypotenuse is 1. Excellent. 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 Let's split the page. There we go. Let's do it again. Okay, so now I'm looking at tangent of cosine inverse of x. So remember, this is cosine what equals x is really what's asking here. But let's draw a picture to help us do this. Cosine is ca, so that's adjacent over hypotenuse. So x is my adjacent, 1 is my hypotenuse. So I would have x for here and 1 for here. You know, almost the exact same kind of algebra. We'd have, you know, x squared plus the opposite side squared. It's going to equal 1 squared. And if you do the same algebra, you get the same thing that you have over in part A. So we'd have the opposite is going to equal square root 1 minus x squared. All right, so now that we're at this point, how does that help me? Well, for tangent, to do tangent, I know that tangent theta is really the opposite side over the adjacent side. And in this case, the opposite side was that crazy radical we figured out, 1 minus x squared underneath the radical. And the adjacent is x. Okay, so slight difference there. Before it was over 1, now it's over x. And that's, worth noting there. Okay, we keep going. Same practice. We're going to draw a picture. Then we're going to find any missing pieces. And then work on the outer trig ratio. So this time, again, we're looking at cosine, ca, which means that this right here is really 2x over 1, and that would give me the adjacent is 2x, and 1 is my hypotenuse. So my picture, I'm going to have 2x here, 1 for my hypotenuse. Now, do I even need the other side? And some people say, do you really need the other side? And there's very few cases when you wouldn't, but take a look at the end product. We're looking for sine, which uses opposite and hypotenuse, so we do need to figure out this opposite side. Often you do, but not necessarily all the time. Okay, so Pythagorean theorem, 2x squared plus opposite squared equals 1 squared. So this is going to become a little note here. 2x squared is really 4x squared, because it's 2x times 2, 2 times 2 is 4, x times x is x squared. Don't forget to square it all. Sometimes it's a small detail, but a lot of people kind of need to remember that. So if I finish the algebra here, opposite is really going to be the square root of 1 minus 4x squared. Alright, so that's check, good. And now we're talking about sine theta. So sine theta is going to be, what is that? That's one opposite over hypotenuse. And the opposite in this case is this crazy radical, 1 minus 4x squared, all underneath the square root. And the hypotenuse is 1. So there we go. That's our answer. Hopefully at this point it's starting to get a little bit easier. If you really want, I would even pause the video, try the next one on your own, and see if you get the same answer I do. Okay, so I have sine of tan inverse of 3x. So, okay, that's really tan inverse of 3x over 1. And we're doing tangent, so toa means that this is the opposite, and this is the adjacent. So opposite is going to be 3x. Adjacent is going to be 1. And then the missing side this time is actually the hypotenuse. So here's my hypotenuse. And I know, Pythagorean theorem, because it's a right triangle, 1 squared plus 3x quantity squared equals hypotenuse squared. So that's going to give me, simplified here, 1 plus 9x squared equals hypotenuse squared. But I'm going to go ahead and square root both sides. There we go. So square root of 1 plus 9x squared is the hypotenuse. So this is square root 1 plus 9x squared. Why do I need to do that? Because here, when we're talking about sine theta is really the opposite side over the hypotenuse side. That's the ratio for that group. So the opposite side, that's not too bad, 3x. And the hypotenuse side is 1 plus 9x squared, all inside the radical. Check. Done. Okay, so I'm going to stop the video here because part 2 of the video actually starts right here at part B and goes forward. So some of it's going to overlap, but that's okay. Good luck, and we will see you in the next video.